So in the previous class, we were discussing about product ciphers, confusion and diffusion. So we will quickly just go through it and then we'll start discussing Feistel cipher. Because all of these topics, which are these product ciphers and the confusion, diffusion, and all these things, they form basis for Feistel cipher. So we need to understand these things first of all, then we'll move to Feistel cipher. So product cipher is, whenever we use uh, a number of things like or a number of techniques like substitution, permutation, uh, S boxes, P boxes, we can call them substitution and permutation. So whenever we use S boxes, P boxes, and other components in combination, then we say that that technique is a product cipher, right? So in Feistel structure we'll be using all of these things. We'll make use of S boxes, we'll make use of P boxes, we'll make use of some functions and some other components as well. So they come under the category of product ciphers, right? So this diffusion we talked in previous class as well. So diffusion, whenever we talk about the diffusion, that means we are talking about hiding the relationship of ciphertext and the plain text, right? So this concept of diffusion, it implies that each symbol in the ciphertext is dependent on some or all symbols in the plain text, and it says that if a single symbol in the plain text is changed, then most of the symbols or all of the symbols in the ciphertext will also be changed, right? So that is the thing about diffusion. uh, that means we are concerned with the ciphertext and the plain text, and if we make any small change in plain text, even if we change a single symbol in the plain text, then most of the symbols or the whole ciphertext will be changed, right? So that is about diffusion. In confusion, we talk about ciphertext and the key. So we hide the relationship between ciphertext and the key, and it says that if you change any symbol or any value of the key, then the the symbols or the value of ciphertext, it is changed, right? That change may be for all of the symbols or most of the symbols in the of the ciphertext, right? So that is the thing with confusion. It talks about ciphertext and the key. It talks about the relationship between ciphertext and the key, and diffusion talks about the relationship between ciphertext and plain text. So just keep these things in your mind. Next thing comes is rounds. So we'll make use of this concept of rounds in Feistel structure, right? So confusion and diffusion, our motive is to achieve both of these properties, right? So we can achieve these two properties using iterated product ciphers. Iterated means we'll be repeating the steps which will be using for the given technique. Okay, we'll be repeating those steps again and again, wherein in each step we will be making use of S boxes and P boxes and other components as well, okay, which we have discussed in previous class. So these P boxes, I told you about three kind of P boxes. So in some text, in some text, we you can you people can find this term, which is D boxes. So don't get confused. The straight P box is called a D box, right? So if you see this term D box, that actually means straight P box. Fine, so we'll be making use of iterated product ciphers wherein we'll be using a combination of these different boxes and other components as well. And each iteration will be referred to as a round, right? So the steps which will be repeating, we call those steps as rounds. We'll be having a key schedule or a key generator which will help us to generate a different key for each round. So the number of rounds you have will be equal to the number of keys. तो हर एक राउंड के लिए हमें एक और नई की जनरेट करनी पड़ेगी, right? And for that purpose we have key generator in the structure. Next point is, in an end round cipher, the plain text is encrypted or decrypted n times to create the cipher text or plain text. So, say for example, if I say any cipher is n round cipher, so that means that I am following n steps for encrypting that message and n steps for decrypting that message. Right, so this is how I call it an n round cipher. Now, say we have the plain text initially, then it goes through a number of rounds, and then at last we get the cipher text, right? Now, these intermediate levels we call them middle text. So we are interested in plain text and cipher text, but we are following multiple rounds. So the text which we are getting in between, we call that text as middle text. Right? So these are the things which will be using. Now, this is an example of a product cipher. That is the representation. It shows you the working of a product cipher, which is made up of two rounds. Right. So here we have this plain text, which is of 8-bit, and we are to generate a cipher text of 8-bit out of it. Right. So what we do is we will have a key generator, right, which will generate key for each and every round. Now in this 8-bit plain text, we have we have made 4 pairs out of it, right? So this is just an example just to make you understand the working of product cipher using rounds. So in this example, we have made these 4 pairs out of this given plain text. Next, we will apply this key which has been generated using this key generator. So the first key we are using for first round is K1. So we'll apply this key, the plain text, right? And after applying this key or after using this key over plain text, what we'll do is we will input we will input the value which we have got after mixing the key to the S boxes. So here we have these 4x boxes for these 4 pairs of the plain text. So this is S box 1, S box 2, 3 and 4. So the structure of these S boxes can be different for different product ciphers, right? So after inputting the value which we have got after this step, after mixing the key, we will input that value to the S boxes, and the output of S boxes will be provided as input to the P box. So here you can see that we are making use of S boxes and P boxes. Okay, both of the boxes we are using over here. So in this P box, some kind of permutations will be done, some reordering will be done. So here you can see this particular value is being mapped to this particular value. So this mapping will be done using P box, and then we'll get some other value over here, right? So this value will be called middle text. Now the value which we have got at this middle text level will be input to the next round, okay, wherein it will be mixed with the key again. The steps will be same for each and every round, but the value of key will be different. So here you can see that we are using this key K2, right? And rest of the processes are same. So this is the S box layer, this is the P box layer, and this is the final cipher text we are getting over here. Right, so this is how this product cipher works in in combination which has the combination of different kind of techniques, which are substitution, permutation, and some other combinations also we can have. Right, so this is how it works with this product cipher works with the rounds. Now we were talking about this making use of rounds to achieve confusion and diffusion, so that the attacker it 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 the attacker may not find the ciphertext or the value of key, right? So confusion and diffusion we can get using rounds and product cipher, as in, see, this example shows you that if you change a single entry in the plain text, then how many bits or characters in the ciphertext are changed. Okay, so that is the thing we talked about in some of the initial slides, that if you change one symbol in the plain text, then most of the symbols or all of the symbols in the ciphertext get changed. And just like this changing values in the plain text changes the ciphertext, so changes in the key will also change the value of the ciphertext. So here you see that this one symbol in the plain text we are changing, right? Rest of the processes are same. So this particular bit was was acting as the input to S4. Okay, S4, that fourth S box, right? So it generates these two outputs, okay, and these two outputs goes to P box, and then it generates this middle text. So just because of this one symbol in the plain text, these two symbols are getting changed, right? In the second round, these two symbols go to S1 and S2, right? So S1 again changes two symbols and S2 again changes two symbols. So in total, four symbols are being changed, right? So just because of this one symbol, the change in one symbol, four symbols in the ciphertext are getting changed over here, right? So that is the thing with the diffusion and confusion, right? So the main idea behind it is अगर कोई अटैकर इसको अटैक करने की कोशिश करता भी है तो अगर एक बिट भी गलत हो प्लेन टेक्स्ट में या फिर की के अंदर, तो उससे सीफर टेक्स्ट की जो वैल्यू है दैट वुड बी समथिंग एल्स, राइट? सो दैट इज द आइडिया बिहाइंड डिफ्यूजन एंड कंफ्यूजन. Okay, now we will discuss these two classes of product ciphers, which is the main topic, जिसके basics हम अभी तक cover कर रहे थे. So this Feistel cipher is very important topic. On this structure, on this Feistel structure, many of ciphering techniques are based, which are used nowadays. So we'll be discussing this Feistel structure in detail. So this Feistel cipher or Feistel structure, you can call it, it uses invertible and non-invertible components. So invertible component means जिनका इन्वर्स हम लोग फाइंड आउट कर सकते हैं, जिनको हम इन्वर्ट कर सकते हैं, एंड नॉन इन्वर्टिबल मीन्स जिनको हम इन्वर्स नहीं फाइंड आउट कर सकते. So Feistel structures, they use invertible and non-invertible components. there is one more kind of component which is called self-invertible. So Feistel structure, they also use that kind of component as well. Non-Feistel ciphers, they make use of invertible components only. So that is the main difference between these two structures. So here we are interested in Feistel ciphers only. Okay, so we'll be discussing this thing in detail. So Feistel designed a very intelligent and interesting cipher that has been used for decades, and it has three type of components: self-invertible components, invertible components, and non-invertible components. Components as in जैसे S boxes हैं, P boxes हैं, या एक special function हम लोग use करते हैं. So these are the components which we'll be using. तो product cipher का ही एक type है. These are classes of product cipher. So product cipher का we have already seen that it make use of a number of components, right? So Feistel structure, it makes use of these three type of components, right? ओके एंड द आइडिया बिहाइंड दिस इज, आइडिया जो होगा फीस्टल स्ट्रक्चर का वो आइडिया सेम रहेगा कि एक हमारे पास प्लेन टेक्स्ट होगा, विल बी हैविंग सम वैल्यू ऑफ की एंड देन विल हैव टू जनरेट अ सीफर टेक्स्ट आउट ऑफ इट, एंड देन एट द डिक्रिप्टिंग एंड सीफर टेक्स्ट से हम लोग क्रिएट करेंगे प्लेन टेक्स्ट को. द आइडिया विल बी सेम. Now that is the first Feistel cipher design which was introduced. इसके बाद इसमें कुछ चेंजेस हुए, तो जो फाइनल डिज़ाइन है वो हम लोग इसके बाद करेंगे. So this was the first thought of a Feistel cipher design. So in this you can see that we are having this plain text, right? And we are having some key, and in component we are having this XOR operation and this function. Okay, and at the decrypting end we have this message which we have encrypted. So here the C1 and C2 are same, right? So this is decryption end. Here again we are using this XOR operation, a function, a key, and as a result we are getting the plain text. So our motive over here is we have to check, after applying all these operations and after using all these components, we have to check that this P1 and P2, they both must be same, right? So जिस वैल्यू को हमने एनक्रिप्ट किया है वही वैल्यू हमें डिक्रिप्शन के बाद मिलनी चाहिए. So इसमें जो इनिशियली जो Feistel स्ट्रक्चर वाज इंट्रोड्यूस्ड, तो उसमें क्या यूज किया गया था? द फंक्शन fk which accepts the key as the input and the output of this component. This component means this particular function. Okay, so the output of this function is XORed with the plain text and the result becomes the cipher text. तो यहाँ पे this function we have, okay, this function is having key as input, then the component, the output of this particular component which we are representing as this arrow, so the output of this component, this fk component, and the plain text, the value of plain text, they both are XORed over here, right? तो उन पे हम XOR operation लगाएंगे and the result which we get is the cipher text, right? So this is the encryption part. Decryption में हम क्या करेंगे? We'll be using the same function over here, okay? जो cipher text है उसको और ये function का जो output होगा उस पे हम XOR operation लगाएंगे and in result we get this P2 which should be equivalent to P1, right? So this function, this fk function, it can be any operation or a series of operations. So इसका जो structure है वो already given है, राइट। सो वो प्रॉब्लम पे डिपेंड करेगा कि क्या इसका स्ट्रक्चर होगा। अगर कोई क्वेश्चन ऐसे होगा भी तो उसका इसका स्ट्रक्चर ऑलरेडी गिवन होगा। सो आई टेल यू विद द हेल्प ऑफ एन एग्जांपल ऑल्सो कि कैसे हम एफ के का यूज करके और के का यूज करके कैसे हम प्लेन टेक्स्ट को इसके साथ एक्सोर करते हैं, एंड देन हाउ डू वी फाइंड दिस सीफर टेक्स्ट। So this is the example. So it says that the plain text and cipher text are 4 bits long, you know, and the key is 3-bit long, right? And we have to assume that the function takes, now here this working of this function is given, right? So we assume that function takes the first and third bits of the key is 3-bit long. So function क्या करेगा, जो f के function है, it will take the first and third bit of the key, interprets these 2 bits as a decimal number, squares the number, and interprets the result as a 4-bit binary pattern. So we have to show the result of encryption and decryption if the original plain text is this one. So plain text की वैल्यू ये है हमारे पास, and key की वैल्यू ये है. So हमें क्या करना पड़ेगा, सबसे पहले we have to use this key to apply or to find out the value of this function. Okay, और function की value find out करने के लिए which series of operation we have to perform, these operation we have to perform. So what it says, we have to take the first and third bits of the key. So first bit is 1, third bit is 1, right? Interpret these 2 bits as a decimal number. So 1 और 1 ये binary number है, so we have to interpret this as decimal, which gives you 3. Then you have to square the number. So after squaring 3, what do we get? We get 9. Okay, we have squared the number. Then interpret the result as a 4-bit binary pattern. Now 9 को हमें बाइनरी फॉर्म में रिप्रेजेंट करना है. सो 4 का जो बाइनरी 9 का जो बाइनरी पैटर्न होगा 4 बिट का, दैट विल बी 1001. Fine. So this will be the output of the function unit, the function component in this particular structure. Okay, इसका आउटपुट अब हमें मिल गया, राइट? एंड द प्लेन टेक्स्ट वी हैव, सो प्लेन टेक्स्ट है हमारे पास, इसका आउटपुट है. व्हाट वी विल डू, विल परफॉर्म द एक्सोर ऑपरेशन नाउ, राइट? सो एक्सोर ऑपरेशन परफॉर्म हम जैसे ही करेंगे, दिस इज प्लेन टेक्स्ट, दिस इज द आउटपुट ऑफ फंक्शन कॉम्पोनेंट, सो वी गेट दिस वैल्यू. एक्सोर ऑपरेशन विल बी परफॉर्मिंग, जैसे हमने प्रीवियस क्लासेस में भी किया था. तो एक्सोर ऑपरेशन जब हम परफॉर्म करते हैं तो जो भी सेम वैल्यूज होती हैं, दे गिव यू 0 एंड डिफरेंट वैल्यूज गिव यू 1. सो दिस विल बी द सीफर टेक्स्ट, राइट, फॉर दिस प्लेन टेक्स्ट. ओके, एट द डिक्रिप्टिंग एंड व्हाट वी विल डू, वी यूज दिस सीफर टेक्स्ट and the function component output, the output of function component. We XOR them and then we find out the value of plain text. So यहाँ पे cipher text की जो value है, this is this one, 1110, and the value of key is 1001, right? और जब हम इसका XOR करेंगे, so ये value आएगी हमारे पास, which is equivalent to this plain text. या यहाँ पे जो हमारे पास इनिशियली गिवन था, राइट? सो यहाँ पे क्या है, जो हमने वैल्यू को या जिस भी इसको ये जो हमारे पास n बिट वर्ड दिया हुआ है, इसकी जो वैल्यू है इनिशियली, दैट वैल्यू वी आर गेटिंग आफ्टर डिक्रिप्टिंग द मैसेज, राइट? सो विच मीन्स कि जो फंक्शन है हमारा, it is working properly. Fine. So this is how it this whole process work. Now this structure, this initial structure, uh, it was, this is self invertible, right? Self invertible means we are using the same key for encrypting the message and decrypting the message. Fine. So what if we are to use any non-invertible element or invertible element? Then how do we make use of it? So for making use of some non-invertible elements in the product cipher, this idea of Feistel structure was improved. So उसको जैसे जब improve किया गया, so we made use of some more components in it. We dealt with the plain text in a different way. So herein, this is the improvement of this previous Feistel design which we have just discussed. So यहाँ पे हम लोग क्या करते हैं, see, we simply divide the plain text and the cipher text into two equal length blocks, and we call them left block and right block. We represent them using these notations L and R. L is for left and R is for right. Now we let this right block to be uh, the input to the function, and we let the left block to be XORed with the function output. So what we are doing is we are using this R block, this right block as it is. So here you can see we are passing it as it is, and the value of this left block, which is the left part of the plain text, it is XORed with the output of the function, right? और आउटपुट फंक्शन का हम कैसे निकाल रहे हैं? We are making use of this R1 and key. Okay, this key is given over here, and this value of R1 we already have with us, right? So जो हमारा cipher text बनेगा, that will again be into two parts. उसका जो right part होगा, that will be same as the plain text, and जो left part होगा, that will be made up of using this XOR operation over the left part of the plain text and this function component. Okay, so this thing you can see from here. Let me erase it. So here you can see this right part is going as it is to the cipher text, and this left part is made up of this L1 and this function. So you can see we are performing this XOR operation on L1 and the function. So it is made up of these two values. Now here we have to remember this one thing, that the input to the function must be exactly the same in encryption and decryption. So इसके अंदर हम जो encryption और decryption के अंदर जो input देंगे, that must be same. अब वो same कैसे होगा? See, here we are using this R1 as the input, okay, and this right part is not being changed, right? So जब हम decrypt करेंगे, so ये वाला जो right part है, that will again be same over here. So right part को will be inputting into the function with the key, and then we'll be performing the function, will be XORing the output of the function with the left value of the cipher text, and then in result we'll be getting the left part of the plain text. This is how this thing works. Now here in this Feistel structure, which was improved from that initial structure, the right part of the plain text, it remains unchanged. Okay, so that creates a problem. So if some intruder attacks in this on the system, then सीधे सीधे जो अटैकर है उसको राइट पार्ट जो है मैसेज का वो बिल्कुल सीधे सीधे मिल जाएगा, राइट. सो व्हाट द अटैकर हैज टू डू, इट हैज टू वर्क ओनली फॉर द लेफ्ट पार्ट ऑफ द मैसेज. Okay, so this was the problem with this improvement. So again, some changes were done to it. And after those changes, we get the final Feistel structure. So here we can also confirm that whether this L1 R1 and L4 R4 are equivalent or not. So here you can see that this L2 and L3 and R2 and R3, they are exactly same. Okay, this is the encrypted message, okay, which we have used for decryption, right. So these parts of the given text are same, and the right part of the message, it is same for each and every level. R1, R2, R3 and R4, they all are equal. Fine. Now we have to check whether this L4 is equivalent to L1 or not. We can confirm this using these expressions. So we can see that this, how we are getting this L4. Let me show you. This L4 is made up of, yes, L4 is made up of L3 XOR this function component, right. So this is the thing which we are doing. ये जो output है, this is L4 और हम XOR किस किस का कर रहे हैं, we are XORing this L3 and this function component, right. So this is the same thing written over here. L4 is equal to L3 XOR F R3K. So here in this function at this particular stage, we are inputting what? We are inputting R3 and K, right. Now we can change this expression into this expression. Why? Because this L3 is equivalent to L2 from here, right? And this R3 is equivalent to R2 from here. Fine. So this expression, it gets changed to this expression. Now we have to check that whether this L4 is equivalent to L1 or not. So we have to change this expression in the form of L1. So here this L2, we can find out the value of L2, how do we get this L2? So here this L2 we are getting by XORing what? L1 and FR1A, right? So this part of this expression is this one. L2 is equivalent to L1 XOR FR1A. Now this R2 is, R2 is equal to R1. So we can write this part of the expression as this one. Okay, we have simply replaced this R2 with R1. Fine. So now we are XORing it, right? XOR operation हम इस पे perform कर रहे हैं, तो XOR operation में अगर same input हो तो the result we get is 0. So these both will be discarded, okay, and we are left with L1. So here it is proved that L4 is equal to L1, right? So that means the message which we have encrypted over here, R वाली जो value है, जो right part है message का, that is same throughout the process, throughout the whole process of encryption and decryption. So we are not bothered about it. तो जो L1 है और जो L4 है उनकी equality हमें check करनी है, right? So यहाँ पे we have proved that L4 is equal to L1. तो यहाँ पे हमने जो प्लेन टेक्स्ट को एनक्रिप्ट किया है और उसके बाद जो उसको डिक्रिप्ट किया है, सो दे both those values are same, right? So that means the system is working absolutely fine. Okay, so next is this the elements of Feistel Cipher design. These elements we have to keep in our mind while designing this Feistel structure. We have to keep in our mind that what block size we have to consider, what key size we have to consider, number of rounds, how how many rounds we have to take for carrying out this operation. द सब की जनरेशन, सब की मीन्स जो हम कीज जनरेट करते हैं हर एक राउंड के लिए, वी कॉल दोज कीज एज सब की. देन द राउंड फंक्शन, जो हमने फंक्शन अभी यूज किया था प्रीवियस एग्जाम्पल में भी, जिसमें हम फर्स्ट वाले में हमने की को इनपुट की तरह दिया, सेकंड वाले में आर और की को हमने इनपुट दिया. So these are some elements of Feistel structure. So block size, की साइज और नंबर ऑफ राउंड्स, इनको हम जितना इंक्रीज करेंगे उतनी ही ज़्यादा सिक्योरिटी बढ़ेगी एल्गोरिदम की, लेकिन जो सीफर है वो स्लो होता जाएगा, राइट. एंड सबकी जनरेशन एल्गोरिदम ग्रेटर कॉम्प्लेक्सिटी कैन मेक एनालिसिस हार्डर, जितना ज़्यादा कॉम्प्लेक्स होगा उतना ही ज़्यादा सीफर है वो सिक्योर होगा. एंड द सेम थिंग विद राउंड फंक्शन, जितना कॉम्प्लेक्स फंक्शन होगा उतना ही ज़्यादा सीफर सिक्योर होगा, right. So that is the final design. So I guess that's all for today because we are running out of time. Okay, so iska jo final design hai that will be covering in the next class.